Final example for this lesson is example number 3. This one, very similar to the other two. We start off by drawing a diagram. It's the same diagram as I've just drawn in the two previous examples. We've got an initial velocity, this time it's u, it doesn't tell us what that is. And we're going to have a curve coming down until it tells us that it hits the plane at a point which is 90 meters of a horizontal distance away from the starting point. So if we draw this across and we draw this up, it's telling us that this is 90, and it's also telling us that we started 122.5 above the initial. So that's the first step, being able to draw the diagram. After that, what you've really got to bear in mind about these questions is there's only two things that you can actually do here. You can resolve things vertically, or you can resolve things horizontally, and you're going to use the Suvat equation for whichever you do. So actually in most of these questions you'll have to do both. And if you're not sure where to start, well, just do one of those things. Write down what information you have and see where it gets you. So let's start with the vertical direction. Right, we're looking for u, but we still know, because it was horizontal, it's projected horizontally, that in the vertical direction u is equal to 0. We know that we've moved down 122.5. I've taken the positive direction as upwards, right? I could have done it as downwards. We'll get to the same answers as I did in the previous example. A is minus 9.8. And then we really have to think about, we've got 3, so we could get the other information. So we have to think about which of those is going to be useful for us. And when you're looking at this diagram, you're thinking, well, if I knew the time with which we were 122.5 below, then I would know that that time was the same time that we were 90 along. So if I find the time in this bit for when we're at this point here where it hits the ground, then I'll be able to use the time in the other part, right? And hopefully that can help me get to a solution. So let's have a look at that to find the time. So we've got S equals ut plus a half at squared. S equals 0 plus 1/2 times minus 9.8 t squared, and s is minus 122.5. So it's minus 122.5 divided by minus 4.9 equals t squared. Obviously the minuses are going to cancel, and we get 122.5 divided by 4.9, and then we square root that answer. So let's have a look at what we get. We get 5. Very nice. So it's 5 seconds that it's taken from you to get from the particle to get from here to a time when it's 122.5 below. But we know at that time we're also 90 meters across. So when we then go and we resolve horizontally, right, we can say that, well, we know that u is the thing we're trying to find here. We know that s is 90, and we know crucially now that the time is 5 seconds. So it's 5 seconds from when we started. We also know, because we're travelling horizontally, that the acceleration is 0. The acceleration will always be 0 when we're horizontal, and always minus 9.8 when we travel vertically. So we pop that in. S equals ut plus a half at squared. And again, put 90 in there. We've got u times 5 here, but all of this bit, 1/2 at squared, because a is 0, will cancel. So we've got 90 equals 5u. So 90 divided by 5 is u, which is 18 meters per second, and that is the final answer. Okay, so all of these questions are variations of the same thing. We're doing resolve vertically, we're doing resolve horizontally, we're using the key points about the accelerations that I've just talked about, and we're using the distances and times being the same in our diagrams that we're drawing. So have a little go. It's exercise 6A. There's only 7 questions, so I recommend you do the odds, and if you feel like you need more practice before we move on to the next lesson, do the evens as well.